In SystemVerilog Assertions, we often need to check signal transitions, stability, or equality between cycles. That's where built-in methods like $rows, $fal, and $stable come in. These methods are fundamental for detecting edges and stability, which are perfect for identifying trigger points or for comprehensive protocol monitoring. For instance, $rows returns true when a signal transitions from 0 to 1, indicating a rising edge. Conversely, $fal detects a falling edge, returning true when the signal goes from 1 to 0. And $stable is true if the signal's value remains unchanged across clock cycles, ensuring data integrity. These methods are crucial for verifying that a done signal asserts within a specific number of clock cycles after a start signal rises, or checking when a reset signal is deasserted. Now, let's look at how we can observe past values and detect any changes in signals. $past lets you look back in time, retrieving a signal's value from previous clock cycles. For example, $past gives you the value of sig, one clock cycle before the current one, while $change checks if the value toggled since the last sample, regardless of the direction of the transition. This is essential for verifying multi-cycle protocols and ensuring that signals remain constant during critical operations. These built-in methods become incredibly powerful when integrated into properties, allowing us to define complex temporal behaviors. Consider this example, property handshake _ check at $rows ###, 1:3 rows in property. This means whenever REQ rises, ACK must rise within 1 to 3 cycles. It's a simple yet effective way to encode protocol timing and ensure proper communication between modules. These methods can also be combined with sequences to create even more sophisticated checks. For example, sequence data _ stable, $rows ##1 stable, *3 in sequence. Here, when valid rises, data must remain stable for 3 cycles, a common data integrity check in many designs. This ensures that critical data is not corrupted during transfer or processing. To summarize, these built-in methods are your toolkit for robust SystemVerilog assertions. With built-in methods, you can write powerful assertions that feel like natural language for signal behavior. Master these methods. They make your verification smarter and cleaner,